Welcome to our video on Chapter 1, dealing with descriptive and inferential statistics. We're just going to make a few brief notes and comments here. You'll still be responsible for items that are not mentioned in the video. But things that you need to know is the difference between descriptive and inferential statistics. Descriptive statistics are, you can think of as just the numbers. The facts. It describes an item. Example, a batting average of 400. Recording the batting average is descriptive statistics. The inferential statistics is to literally make an inference. This is a good batter. It can be misleading in the sense of perhaps this person batted 5 times and got 2 hits. In that case, it's deceiving in the sense that there's not enough information to go with. If they've batted 100 times and got 40 hits, a little better. 1,000 times, 400 hits, then we're pretty sure what's going on. But you have to be sure when you're looking at these and you're making your inferences that you have enough data to go on to make a good inference. Another item are types of data or variables. That would be qualitative, which is based on a quality or characteristic. Example, color. You can't calculate a color, you can't add it, find an average, anything like that. A quantitative is numerical and measurable. Example, temperature, height, number of, and then fill in the blank. Number of cars, number of people, any of those. Just because something has numbers does not make it quantitative. For example, a social security number. That's qualitative. It is a characteristic. It names the individual. It does not give them a worth. So that's an example where you have to be careful that just because it does have a number does not make it a quantity. Another couple things. are the difference between discrete and continuous. Discrete values are typically integer amounts, and I'm going to put that in quotes because what it actually is are defined steps. Number of blank, that's descriptive, or excuse me, discrete. Shoe size would be discrete. There's a 9, there's a 9.5, there's no 9.375. So even though it's not an integer, it has a definite step size. Continuous, just like it says, there's no step. Example, time, temperature, height. We typically record our heights as, say, 5'9" or 5'10" or 5'9.5", but at some point in time a person would be 5'9.3798, etc. You don't jump by half inches, just the recording amount is what is jumped. There are also what are called levels of measure. The different levels, one would be nominal. That's the least restrictive. It merely names an item. It's a characteristic. Definitely qualitative data. A second type is ordinal. It is nominal with order. Example, small, medium, large, extra large, etc. That's a definite order on the items, but you can't add those up and say I have an average of a small and a half. So those two are both qualitative data. When we get to the third and fourth type, they are quantitative data. The first type is called a ratio level of measurement. And the idea is that there is a ratio between two items, between two particular values. One way to key on that is to think there is a true zero. An example is money. If I have $0 or 0 rubles or 0 euros or 0 yen, I'm flat broke. It doesn't matter. If I have $5, I have 5 times as much as somebody who has $1. The fourth type is called interval. It's just like ratio, except there's no real true value, and you can't say one is twice as much as the other. or something like that. Example would be temperature. 0 degrees Fahrenheit is not a lack of temperature. It's still cold. So that's the difference there. It's also not 0 degrees Celsius. That again is not a lack of temperature, but it's a different amount of calling something 0. So the key on that one is the idea of a true 0, and they are both quantitative data styles. There are different items that you will need to also be aware of in Chapter 1, but those are kind of the big highlights to think about.